So now let's continue with question 7 and do part B. So in part B, we want to show that this integral is inversely proportional to k. So let's rewrite that integral down here and then try and see what it evaluates to. So it's from the limits of 2k to k, 2 over 2x minus k squared all squared dx. Let me just double check that. 2 over 2x minus k all squared. So right, let's evaluate this first. Let's see what this gives us, and then we can check if we've shown that it is inversely proportional to k. So the easiest thing to do is just to make it a bit clearer to see how this expression does integrate. Maybe let's bring this squared bracket up. So let's rewrite this then as 2k to k, 2 times 2x minus k to the minus 2 dx. I always like to pull out the constant in front. It makes it easier to integrate a little bit. We have 2x minus k minus 2 dx. And so if we integrate this, what we can do is we're adding 1 to our index. So it's 2x minus k to the minus 1. And from there, I always think about what do you get if you work backwards? Well, if you differentiate this, you're going to get a minus 1 in front. Of course, there's no minus 1 here. So then if you're going to get a minus 1 when differentiating, then you need a minus 1 to cancel that out. And then when differentiating, you're also going to have to differentiate what's inside the bracket. So you're going to get a factor of 2. In fact, that's this factor of 2. So you didn't necessarily need to pull it out. I always do. But if, for example, we ignore this factor of 2 and we know that there needs to be no factor of 2 in front of this expression, then that means we have to divide what we get here by 2. So we have to multiply by a half. So then this becomes minus a half. I'll just rewrite it here. This is minus a half 2x minus k to the minus 1. So that's just this integrated, right? And then if we multiply through by the factor of 2 again, we're doing 2 times all of this. So then we do just get minus 1 in total. So then that's just minus 2x minus k to the minus 1. And we're evaluating it. So this is a working step. This is not actually our answer there. That was us sort of working through it. And technically, we'd want a plus c if we're not including the limits. But we're evaluating this between 2k and k. So if we do that, we're looking at, let's take out the minus. That is helpful. And then we can rewrite it however you find. You can rewrite it however you find it most useful or easiest to look at. And so we have this between 1 over 2x minus k, between 2k and k. So let's have a look at that. That's 1 over 2 times 2k minus k minus 1 over 2, or x is k now, 2k minus k. And so let's look at what each term becomes. So we have a minus at the front, 1 over 2 times 2k minus k. So this is 4k minus k. So we get 1 over 3k minus 1 over k, like that. And from here, all we really need to do, because our goal is to show that this is inversely proportional to k. So imagine, let's call the result from this m. We're trying to show that m is proportional to 1 over k. that means it's inversely proportional to k. So m will be some constant n over k, right? So we can see that the result of this integral up here ends up being this. And we can clearly see that we can pull out 1 over k. We can pull out 1 over k. Let's keep the negative sign there for a moment. If we pull out 1 over k, we get 1/3 minus 1. That's minus 1 over k multiplied by 1/3 minus 1, that's minus 2/3. So we get 2 over 3k. So that's the equivalent of n being 2 over 3. Our k is just our k, so we have our result for our integral m is equal to 2 over 3k, so m is equal to n over k. And so we have shown that in part B, the result of this integral is inversely proportional to k. Okay, so that's question 7. So in the next video, we're going to look at question 8 of the same paper.